Okay, so in this video, we're going to be solving this problem right over here. So we have 6 raised to the 2x plus 2 multiplied by 6 raised to 3x is equal to 1. So immediately I look at this, I just have this tendency, I want to add these two, right, to get a common base. Let's do that. So this is going to be 5x plus 2 is equal to 1. Now what can I do? Now you're kind of at a position where you can't really do much, right? You're kind of stuck. And so, you know, I'm like, how can I convert this to equal to this, or maybe this to equal to this? I can't really do anything. I'm kind of confused. Don't be confused. Go back. If you're confused on this step, try to go back. Maybe you can do something else here. So what I can do, and another thing I noticed is we have this 2x plus 2, and we can factor out a 2. Is that going to be useful? Well, it seems like it's going to be useful at first, and you might be confusing a theorem or a rule that we just used. So you might be thinking, oh, we can just write this as 6 raised to the 2 times x plus 2, which is equal to 6 raised to the 2 times 6 raised to the x plus 2. This is not equivalent. This is not accurate. The rule goes like this: a to the b times a to the c is equal to a to the b, not times c, but plus c plus c. So this is not going to work out. You might be thinking, okay, I can do 36 divided by 36, and then we'll have a common base, because we can write that as 6 raised to the negative 2 power, and so on and so forth. But that's not going to work because this is not equivalent. So that's not going to help us too much. What's the next thing? You just gotta think. You gotta think through this, right? I actually can go ahead and think about something just so intuitive. I can just divide by 6 raised to 3x, or this one. You can do any of them. I'll do this one because it doesn't have a plus and all that, so I don't want to get confused. Now this is easy. This is easy. Remember, whenever you have something something that has an exponent in the bottom, you can bring it up by making it negative. I made a separate video on this. I went in this in detail. So 6 to 3x, we can write that as 6 raised to the negative 3x. Just make the negative. If we were to do it in another way, like for example, let me do it actually here. 6 raised to the 2x plus 2 times 6 to the 3x equals 1. We can actually divide by 6 raised to the 2x plus 2 if you wanted to. These would cancel. This would be 6 raised to the 3x is equal to. Now, you can push this on top and make the whole thing negative, not just the 2 here or the 2 there. It's a whole thing. So yeah, we have to solve both of these now. So this is going to be 6 raised to the 2x plus 2. We can actually set the top exponents equal to each other. Let's do that. So this is going to be 2x plus 2 is equal to negative 3x. We can subtract 2x is going to be equal to negative 5x, which is equal to negative 2 by 5, negative 2/5. We have to plug it back in and check, but this is what I get. Let's see here. It's going to get 3x is equal to negative 2x minus 2. Add 2x, it's going to be 5x is equal to negative 2. We can divide by 5. This is also going to be x is equal to negative 2/5. Just because we get it twice doesn't mean that it's the right answer, because we just did it in a different way, but that's the same thing. Let's plug it in now. Let's do our check step. So 6, can't see that, 6, there you go, 2 raised to the 2 times, so it's going to be negative 4/5, right? 2 times negative 2/5 is going to be negative 4/5 plus 2 is multiplied by 6 raised to the negative 6/5, negative 6/5 right over there. This is equal to 1. Well, let's see. How is this going to be equal to 1? Well, maybe they're going to add, this is going to be add together, and it's going to maybe give you 0, maybe. I don't know. I'm just guessing. So negative 4/5 plus 2 is going to be, so 2 can be written as 10/5, right? And that's going to be 6/5, right? 6 raised to 6/5. Yep, what I said was right? What I said was right, because we can see that it happens. And it has to happen because whenever you have an exponent and it's equal to 1, we know that the top has to be equal to 0. For example, like 2 raised to the x power is equal to 1, for example. X can be 0 in this case, right? Or what we can do is we can just natural log both sides, right? Natural log. x times the natural log of 2 is equal to 0. Divide by anything here, it's going to still be 0. X is equal to 0. That's our solution. So that's a quick way of thinking about it, right? Anyway, this is going to be, well, you could have also worked it out, and you would have got the same result. 6 to 0 is 1. 1 is 1. That's true always. So our answer ends up being negative 2/5, and we are done. Hope you found this video helpful.